Good morning students. Today we will discuss the last topic, that is atmospheric pressure of chapter 6, Force and Pressure. As the title suggests its meaning, atmospheric pressure means pressure exerted by atmosphere or air, known as atmospheric pressure. We know very well that Earth is surrounded by a thick blanket of air known as atmosphere. So this atmosphere has air, and air is a mixture of various gases which have their weights. So as per their weights, gases in the air, or I can say air, exerts pressure on all the objects on the surface of Earth, known as air pressure or atmospheric pressure. So, air around us exerts a pressure on all the objects. It can be living organisms and it can be non-living things. So, this air around us exerts pressure on all the objects such as living organisms and non-living things, known as air pressure or atmospheric pressure. It can be specifically defined as the force exerted by air on the unit area of the surface. So, air around us applies force on the unit area of the surface. In this way, it applies pressure on that surface, on the objects present on the surface. Now, I am going to tell you few activities based on air pressure. Take a deflated balloon, then blow air into it. Now, as you blow air into it, as you push air into it, that air exerts force on the unit area of the surface of the balloon. In this way, that air exerts pressure on the surface of the balloon. As a result, that balloon increases in size, that balloon elongates. In this way, we can show that air exerts pressure on the surface. In another experiment, we take an inflated balloon which is filled with air. Now, press that balloon from any of the side. Then what will you feel? You feel that a pressure is applied on the surface of balloon as well as on the hand from inside. As you press the surface of the balloon, in turn, air inside the balloon also applies pressure on the surface of balloon and on your hand, which you can feel. So this activity also shows that air applies pressure on the surface. In one more activity, we take an old tin can and fill it with water up to its half level. So firstly, you have to take an old tin can, then fill up to its half level with water. After that, boil water present in it for few minutes. As the water starts boiling, it produces steam, and that steam pushes out all the air present in it outside the can. Now, with the help of tongue, pick this hot old tin can and stop boiling water now. Now put this can immediately in crushed ice. Means you have to dip this hot old tin can in crushed ice. then what will happen? We will see that this cane will be crushed, will be collapsed like this. Why? Because as you start boiling water present in it, that water starts producing steam. That steam pushes out all the air present in it outside. Now there is no air, only steam is there. That steam applies pressure on the surface of tin can from inside, and air outside the tin can also applies pressure on the surface of tin can from outside. So both these pressures balance each other. Then you stop heating this water and quickly put this hot old tin can in crushed ice. Then what happened? As this is dipped in crushed ice, steam present in it escapes out. Now there is no air and no steam in the tin can. So from inside no pressure is exerted on the surface of tin can. But from outside air is there. So air pressure is applied on the surface of tin can, which is not balanced by inside pressure. So this tremendous outside pressure exerted by air on the surface of tin can make the tin can collapsed and crushed. So in this way we can show that air exerts pressure. This air exerts a lot of pressure, a tremendous pressure on us, on all objects. So body fluids present in our body such as blood, water, they also apply pressure from inside on our body, and air applies pressure from outside on our body. So both inside and outside pressure balance each other, and we are able to survive and live properly, comfortably. Now, uses and applications of atmospheric or air pressure. First of all, when we use a straw or a dropper or an injection syringe, what we do? See, for example, you are using a straw to drink juice. Then what happened? Its one end is in the juice and another end is towards your mouth. Then with the help of your mouth, you suck all the air present in it. So now there is no air in the straw. So air pressure reduces in the straw. But outside air is there. So outside there is more air pressure. To balance outside air pressure with the inside pressure, liquid is raised in the straw. Liquid moves up in the straw. In this way, air pressure helps you to drink or to suck juice or any other liquid with the help of straw. In the same way, in dropper or in injection syringe, what do? You press its one end so that air present in the dropper comes out, is sucked out, then outside air pressure increases and inside pressure decreases. To balance inside pressure with the outside pressure, the liquid is made to rise up, that liquid pulls up and then it increases the inside pressure, which balances the outside pressure. In the same way, in injection series, you pull the syringe. As you pull the syringe, all the air present in the syringe sucks out, pushes out. So this reduces the air pressure inside, and outside there is air, so there is more air pressure. To balance the outside pressure with the inside pressure, medicine is sucked into the syringe, so that now any liquid or medicine is in the syringe, so pressure inside the syringe increases, which balances the outside air pressure. So in this way, air pressure help us to drink juices, cold drinks with the help of straws, to fill injection syringes or droppers with medicines. Now next use or application of air pressure. You must have seen that in many toys and window mates, rubber suckers are used. How do they work? See, when you are sitting in the car or you are traveling in the car, then you used to keep a rubber sucker over the window glass so that you can protect yourself from sunlight. So as you press that rubber sucker on the glass window, then air present between rubber sucker and glass window escapes out from the sides. Now there is no air or very less air between rubber sucker and glass. So it results in no air pressure or negligible air pressure between rubber sucker and glass window. Then outside there is air pressure which is applied on the rubber sucker, which makes the rubber sucker to get stuck with glass window, to get attached with glass window firmly. In this way, outside air pressure attaches that rubber sucker with the window glass firmly. Now, third application or last application which we are going to discuss. Tires are filled with air. So, tires of the vehicles are filled with air. Air present in the tires apply pressure on the surface of tires so that they can easily move on roads. So these all are applications and uses of air pressure. One more important thing regarding air pressure. As we go up to high altitudes, the density of air decreases. Air becomes light. Its amount decreases. So air pressure also decreases. So at high altitudes, at heights, you experience less air pressure because of less air. This is the reason that why do we feel lightheaded on hills or on mountainous regions. Because in hilly areas or in mountainous regions, density of air decreases, means amount of air decreases. So air pressure also decreases. So outside air pressure on our body decreases, which makes us to feel lightheaded. And you must have noticed that when we are in aeroplane at high altitudes, at great heights, then we generally have bleeding in our nose. Why? Because at high altitudes, at heights, air decreases. So air pressure decreases. So outside air pressure on our body decreases, but body fluids present in our body like blood, water, they apply same pressure on the body. So inside pressure increases and outside pressure decreases, which makes the blood to flow out, to move out in the form of bleeding. This is all for today. Thank you. Have a nice day.